Hello and welcome to our second week of Newton's Laws. And today I want to build some bridges between what we learned last week and what we're going to learn this week, all of which is about what Newton wrote down in his laws. And so I thought that we should start maybe with a little elephant. Alright, I'm not very good at drawing, but there's my elephant. And I'm sorry, my window and stuff reflects on here, nothing I can do about it. So anyway, there is the elephant, and the elephant is floating around out in space. Okay, these are stars. I know they're like opposite. They should be yellow, but I only have black, green, and blue markers today. So he's floating out in space. Does he have inertia? Yes, he has inertia. Check. And why does he have inertia? What does he have that gives him that inertia? And again, if you need to pause to answer questions, go ahead and do that. The reason he has inertia is because he has mass. And mass is equivalent to inertia. Does he have any weight if he's floating around in space? No, there's no weight in space. No weight in space. Why isn't there weight in space? What pulls you down here on the earth to give you weight? Yes, gravity pulls you down to give you your weight. And let me show you our connection. So Newton's second law says, right, F equals ma, right? And so weight is just a force, right? So I'm going to make this the force of weight. Okay, you can see Fw, we can just write that as W. And what's accelerating you to give you your weight? Well, it is gravity. So we just changed that A to a G, and this week's equation is the same as Newton's second law from last week. It just has 9.8 in there for gravity, negative 9.8 meters per second squared, and that will give us a weight that is directed in what direction? Downward. So that is weight. And then there's one more thing we're going to do. I'm going to put the elephant on the earth. Now he has weight. Check, check. Now he has weight because he's being pulled down towards the center of the earth at a rate of negative 9.8 meters per second squared, right? And then what's going on here? Let's see. So the earth is pulling the elephant down. That's the weight, right? M times G. There is a force that is balancing that, right? There is a force that is balancing that out. It is called a action-reaction force, which is Newton's third law. So this is the earth pulls the elephant down, and the reaction force will be the elephant pulls the earth up. Action, reaction, pairs of forces. These are equal and opposite. Equal and opposite forces. That's Newton's third law of motion. And they are on opposite objects and equal forces. Another example might be that, let's see, the bird, which you can't see very well with the window, but anyway, the little bird here pushes down on the elephant, and the elephant pushes up equally on the bird. And if the elephant didn't hold the bird up, if the earth didn't hold the elephant up, then it would fall. The elephant would sink into the earth. The bird would sink into the elephant.